Today we'll be teaching you how to verify a trigonometric identity using the Pythagorean identities. This lesson will require you to learn about the Pythagorean identities and the basic trigonometric identities such as sine x equals 1 over cosecant x before moving on. Please be sure to look at our article online about it for more information and a list of identities to help you verify trigonometric identities. Now, let's begin.
First, let's do an example of verifying a trigonometric expression. We have secant theta over cosecant theta equal to tan theta. And we want to turn secant theta over cosecant theta into tan theta to verify. Next, we will turn secant theta over cosecant theta into terms of cosine and sine. We will turn secant theta into 1 over cosine theta. And we will turn cosecant theta into sine theta over 1. Since it was in the denominator, it will now be inside the numerator. Next, we will multiply them together and we'll get sine theta over cosine theta. And we will turn that into tan theta, which verifies the expression. When you verify there are two expressions on each side, it is okay to work on either side. So what does it mean to verify something? It means to check something, right? Well, that's exactly what you need to do at the end of verifying an expression, to check.
When you verify there are two expressions on each side, it's always okay to work on either side of the equation, but remember again, you have to rewrite the equation down. When working on one side, you can stop working on that side and work on the other side if you would like. This would mean you need quotation marks on the one you are not solving for anymore. For starting with an example, here are a few tips. Start with the more complicated looking side because probably 90% of the time it would be easier to start with the complicated side. Use your algebra skills to help simplify and change the expression. This means using the conjugate, rationalizing, combining like terms, and factoring. If you need to change the expressions in terms of sine and cosine, use your identities that are provided in your textbook or by your teacher. If you don't have them there, here is a link to a list of identities in the video description and on our website.
Here are the three Pythagorean identities. Here is the original one. For the original one to become this one, you would have to divide sine squared x by the original one to get 1 plus cotangent squared x equals cosecant squared x. To get this one, you would have to divide the original one by cosine squared x to the original, which would be tan squared x plus 1 equals secant squared x.
Now let's try an example using the Pythagorean identities. So here we're given an expression. 1 plus secant squared x is equal to sine squared x plus tan squared x times cosecant squared x plus cosine squared x. You know you can work on either side, so for now let's work on the right side since it looks more complicated. So for the side you aren't doing anything to, always remember to always bring it down when you are rewriting the equation.
First, you want to expand the tan squared x times cosecant squared x, like that. When you simplify it, it becomes 1 over cosine squared x. And now, when you simplify it even further, you see that sine squared x plus cosine squared x are 1. And when you put it together, you get the answer 1 plus secant squared x. And over here you see the two match each other, so you check it. And that's how you verify an equation. Remember, you need to have previous knowledge about the Pythagorean identities ahead of time. Please visit our website for more information.